Hey everyone, so let's solve this LeetCode medium problem, minimum average difference. So it might be tagged as medium, but it is on the easier side only. So let's see the problem statement. So we are given a zero index integer array nums of length n. Now we define the average difference of the index I as the absolute difference between the average of the first I plus 1 elements of nums and the average of the last n minus I minus 1 elements. So for example, if we are considering this index I, then we calculate this left average as the sum of means I plus 1 elements, and then right average will be simply the average of remaining elements. Okay, now both the average should be rounded down to the nearest integer. That means we are not calculating double values here. Okay, now we need to return the index with the minimum average difference. So we need to calculate this left average as well as this right average. Then we take the absolute difference of these both of these values, and then for each index I will be finding this average difference, and we need to return the index which corresponds to the minimum average difference. Okay, and if there are multiple like indices which have the minimum average difference, we need to first return the first index which gives that in. So hence we need to return the smallest one. Hence the constraints can go up to like length of n can go up to 1e5 as well as the elements can go up to 1e5 as well. So let's see the input here. So we are given the input as suppose this. So for each I from 0, 1, 2, 3, 4, 5, we'll try to find out the the average difference that we want. That means calculate the left average, the right average, and then take the absolute difference. So for example, for index 0, what we'll have, the on the left side we'll have this 2 only. Okay, and on the right side we'll have these many elements. So hence, since on the left side we only have a single element, so it will be simply sum divided by number of elements. So 2 divided by 1, and minus it will be sum of these elements divided by number of elements. So number of elements are 5, and sum divided by number of elements. And we simply take the absolute difference. So absolute difference is equals to 3 in this case. Okay, similarly we'll find this for index 1 as well. So for index 1, the left average will have elements 2 and 5. So total 2 elements, so 2 plus 5 divided by 2. This will be the left average, and the right average will be 3953. So sum of these elements divided by 4. So similarly we will be getting the left average as well. Means we'll find out the difference, and this will be the minimum average difference for index 1. So we see like since 2 is less than 3, so now the minimum average that we have found so far is 2, and it occurs at index 1. Now at index 2 as well we found the average difference as 2 only, but we know like since we need to return the first index which corresponds to the smallest minimum average that we have found so far, since index will means the current answer that we have will be at index 1 only. Okay, now we got average difference as 0. So since this is the minimum, so the index will be updated with 3, and similarly we will move, and we saw like since 0 is the minimum that we could found, and it was present at index 3, so hence will be the output will be simply this index 3. Okay, so hence this is the approach to solve this problem. What we will do, for each I we want to find the sum of average of left I plus 1 elements and the average of remaining elements, and then take the absolute difference and then return the index which corresponds to the minimum average difference. So what will be the naive approach of solving it? We simply do what we have done in this input explanation. So what we'll do, will for each I from 0 to n minus 1, what do we need? We want to find the left average. Left average means it is sum of starting I plus 1 elements. Then sum from 0 to I and divide by I plus 1. Okay, so this is the left average. We will simply take the a floor of this, and then the right average will be what? The sum of elements from I plus 1 means all the remaining elements, n minus 1. So the number of elements here is n minus means r minus l plus 1. So it will be simply n minus I minus 1. Okay, and we'll again take the floor here. And now at each step what we will find? We'll find the current difference that we have is simply what? It is absolute of the left average that we got minus right average. Okay, and now what do we want? We want to find the index corresponding to minimum average difference. So we can simply maintain a minimum average and initialize it with a very large value, as well as we need to find this minimum index as well. Okay, so now what do we need to do? If the current difference that we have, if the current difference that we have is simply less than the minimum difference that we have found so far, then what we'll do, we'll update this minimum difference with this current difference, right? Now the index I is the one which gives us this minimum difference, and as since this I is giving us the minimum difference, so hence we will update this minimum index as well with the current I. Okay, and we'll keep updating it for each I from 0 to n minus 1. Now our task at hand is to simply find this left sum as well as right sum. So what we will do is, for each I we'll simply run a loop from 0 to I, and another loop from j from I plus 1 to n minus 1. We'll be able to calculate these sums, left sum as well as right sums, and then we'll be able to calculate these two values. Okay, so hence will be done in like big of n here and big of n here, so overall we'll be done in big of n square, right? So let's see the code for this approach, the brute force approach. So what we'll have, we'll initialize this min difference as a maximum value, so that we are getting able to calculate the minimum, and we initialize it with minus 1. Okay, currently we do not have any starting index. Now we find the left average as well as the right average. So to finding out the left sum, we'll iterate from 0 till I. We'll find the left sum. Similarly, we'll find the right sum by iterating from I plus 1 till n minus 1. Okay, now we'll calculate the left average. So left average will be simply left sum divided by I plus 1. And now if I equals to n minus 1, then in the left average we'll have n elements. So in the right we'll have 0 elements, right? So we need to check before dividing by this element, right? So we need to check like whether this value is not 0, because if then we'll simply divide the sum by 0 and we'll throw an exception. Okay, since we need to check whether this I is less than n minus 1, in that case only we'll be dividing it, else this right average will be simply 0. Okay, and now we find the current difference that we have. Current difference is simply absolute of both the values. Now if current difference is less than minimum difference, we'll update the minimum difference and update our min index with this particular I, and finally we'll be returning this min index. So what will be the time complexity of this approach? So this thing is taking big of n, and this sum calculation that we are doing is also taking big of n only. So hence the overall complexity would be n square, and the space that we have used is constant here. So now let's see the constraints. So since n can go up to 1e5, so this will be of the order of like big of 1e10, and this will give us TLE obviously. Okay, so hence obviously we need to like what optimization can we do here? So we'll obviously like need to iterate through all the elements, right? So this big of n we cannot avoid, but maybe this some calculation that we are doing, maybe we can optimize this part. So what we'll do, we'll simply, instead of using a loop, we can move this left sum part to out of this loop. Okay, now once we out of this loop, now when we reach a particular I, will be maintaining a continuous sum of the I values. Okay, so now when we move from I to I plus 1, what we'll do, we'll simply increase our left sum by this value. So this left sum variable, if we maintain it outside, then it will be maintaining the sum of current I elements, I plus 1 elements. Okay, and now we can simply maintain a total sum as well. We can calculate this total sum initially only, and then we'll be able to find out this right sum as simply this total sum minus the left sum that we have calculated. Okay, so hence we'll be able to find this right sum as well in constant time. So what we're going to do is, we can simply bring this out of this loop, so we'll be able to calculate this left sum in constant time, and once we have the left sum, based on the total sum that we have, we'll be able to calculate this right sum as well in constant time. And now everything else, means everything, this part will remain the same only. This calculation, everything remains the same. We just need to optimize this part, and we'll be able to do that. So how we'll optimize it? Everything else remains the same. What we did, we calculated this total sum. This is the extra part here, and we simply maintain a running sum for the left sum. So we'll increase left sum by nums of I. So now left sum will be having all the sum of elements from 0 till I. Okay. Now, and the right sum will be simply total sum minus left sum. So instead of like running a loop, it was running a loop. Now we are able to calculate both the values in constant time, and this part remains the same only. So now we have optimized from the n square approach to simply this big of n, and all the operations inside is constant only. So this is like the optimized approach of the order of n, and we have used constant space as well. So maybe like we can create a prefix sum array as well, and then find out this left sum as well as right sum. But we know, like, since we only need to find the prefix sum, so we can simply store it in a variable only. Okay, So this was a simple like approach for this problem. Let's try to submit this code as well and like see. So this is the same code that we discussed, the optimized one. We simply create this prefix sum or left sum and maintain the running sum, and we'll be able to do it in constant time, and it runs in 6ms, which is fine because n can go up to 1e5. Okay, so this like was a pretty simple problem for today. We simply needed to do what the question asks us to do, and then like we saw like we need to find this sum in constant time. So obviously we'll use some concept related to prefix sums, and on the basis of that, instead of creating a vector, we simply created a variable only because we need the prefix sums only. We do not need the range, means sum of a particular range which can change. Okay, so yeah, this was the like discussion on this problem. I hope you were able to like follow along with the approaches, and if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining, feel free to comment down. I will be happy to respond. Thank you so much for watching.